Welcome back in next part of quantum physics. In this video we covered two topics, that is classical and quantum theory of photoelectric effect. Second one is Compton effect. As explained in previous video, the photoelectric effect was discovered by Hertz. It was not understood at its earliest stage. Later on, it was discovered that particles emitted in photoelectric effect was electrons. But classical wave theory of light fails to explain this phenomena. The maximum kinetic energy acquired by the electrons remains same, does not depend upon the source, either weak or strong. However, the energy of electrons depends upon the frequency of light. The amazing fact is that when light is turned on, the effect immediately starts. Or we can say the photoelectrons emitted instantaneously. Finally, the answer provided by Einstein in 1905. He proposed that light composed of small bundles of energy or particles called photons. Photons have material characteristics like energy and momentum, and wave characteristics like frequency and wavelength. The energy of photons directly proportional to the frequency and inversely proportional to the wavelength. So, lower energy photons have lower frequency and longer wavelength. Now come to the quantum theory of photoelectric effect. It's also named as Einstein theory. This effect becomes simple by the assumption of Einstein. What is that great assumption? The assumption is the kinetic energy of ejected electron is equal to the photon energy of incident minus the energy required to remove an electron from the material. He also named that required energy as a work function. It is clear that outcoming electron always have less energy as compared to the incident photon. Mathematically, Einstein energy can be defined as E is equal to h nu, where h is Planck's constant and nu is frequency. Or we can write E is equal to hc upon lambda, where c is the velocity of light, lambda is the wavelength. This formula not only applied to the light but also to the particle, as proved in this photoelectric effect. This fact oftenly named as wave-particle duality. In 1922, Compton performed an experiment by using X-rays incident on a carbon block. He observed an unusual result, that is, X-rays scattered from a material. According to classical theory of electromagnetic waves, is that when electromagnetic waves scattered from an atom, the wavelength of scattered radiation is expected to same as the incident radiation. Then Compton explained this phenomena by the help of quantum theory of radiation. The quantum theory of radiation is the radiation consists energy packets, that is photons. The expression can be derived for the change in wavelength by applying law of conservation of energy and law of conservation of momentum. It also known as Compton shift depends upon scattering angle. Have a look on important points of Compton shift formula. As we mentioned earlier, Compton shift formula lambda final minus lambda initial is equal to h upon m naught c into 1 minus cos theta. First case, when theta is equal to 0. It means no scattering of radiation takes place, hence there is no change in wavelength of radiation, which is the case of unmodified scattering. Second case, when scattering angle equal to 90 degree, then lambda dash minus lambda is equal to h upon m naught c. Put the value of h, that is Planck's constant, m naught for electron, that is 9.1 10 to the power minus 31 kg, and velocity of light c is equal to 3 into 10 to the power 8 meter per second. After the calculation, we get lambda dash minus lambda is equal to 0.0242 angstrom. third point is when scattering angle equal to 180 degree, then shift becomes twice, that is equal to 0.0484 angstrom. It's time to differentiate between photoelectric effect and Compton effect. First one is photoelectric effect occurs in bound electrons, while Compton effect occur in free electrons. Second one is the photoelectric effect. Energy of photon is absorbed by the electron, while in Compton effect, photon is scattered. In next video, we cover three topics: de Broglie wave hypothesis, wavelength and velocity of de Broglie waves. Third one is experimental verification of de Broglie. Thanks for watching this video.